Okay, so what's a universal joint? What do we mean by that? There are lots of examples of them. I have them at different scales here, and it's essentially used where I want to turn the twist in one location into another, but I have some sort of displacement, either an up and down displacement, or even in this displacement up and down and then side to side. And I can still turn one tube and the other one still turns at the exact same speed. Now, these are in cars everywhere. They're called constant velocity joints, or CV joints is what you'll hear. But exactly one U-joint or one universal joint will actually not operate at constant velocity. This middle stretch in this demonstration is actually moving at a slightly different rate than the tubes on either side, and this has to do with the anatomy of actually that joint, which we'll look at now. So a U-joint is comprised of a cross and then two forks. Each one of the legs of the cross has a bearing on it that allows it to freely spin. So together, just in this demonstration, you have one piece turning, one fork turning the other fork. Also 3D printed an example here. This is called a double cardan joint. Now, cardan was an Italian physicist in the Renaissance and developed this universal joint. In fact, that term is still used to this day, a cardan joint or a double cardan joint. So this allows some displacement between one tube and another. So we're interested, obviously, for this example, right, where I have two tracker sleds and that there's a difference between their inclinations, so that I have to be able to get the twist or the torque in that tube across those boundaries between those two. So this is why we're thinking of this same double U-joint, this double cardan joint. But as I mentioned before, this double joint exists at the back of every tractor, and this is what it looks like. This is called the PTO drive shaft. So PTO stands for power takeoff. It's essentially the amount of horsepower of a row crop tractor that can be put to use to drive implements in the back. So implements need power, right? They have hydraulics, controls, lots of things, but the vast amount of power transmitted between the row crop tractor and the implement is driven through this PTO shaft. So you'll see that the PTO shaft has a couple nifty features that are exactly what we need. Now these are meant to spin at 500 or 1,000 rotations per minute, right? We're talking about one rotation per day. So the scale, the engineering behind the strength of these may not be relevant, but just the idea of this is. So you can see as it attaches to, say, the PTO shaft, there's a bunch of these configurations of grooved shafts that will mate with the drive shaft and then a pin locator, right? So they connect in that way. But the tractor, the implement could be low, the PTO takeoff could be high, and power is able to be transmitted. Again, so this is one U-joint, and this is the other, one at the implement, with the drive shaft. The other thing that's really relevant for us is the fact that when I have a difference in inclination, I have a greater length, right? This is the other thing that's built into all these drive shafts. In fact, these slide so that you can have one drive shaft that can connect to many different implements at different locations. And if we literally slide these two pieces apart, we'll see that the actual shaft is configured so that it can transmit great torque, right? Like as close to a circle as possible. But it also has a different shape, in fact, many different shapes of these shafts, so that they don't spin, right? So that you can get the torque but no spin. There's a male end and then a female end, one fitting inside the other, right, to complete this. So the idea is that with less weight, but the same concept, this idea of being able to have one tracker sled's torque tube and the other slightly out of alignment, right, between, for lots of different reasons, one lower, one higher, one shifted ever so slightly, that as long as we're able to do this sort of double universal joint in there, we should be able to handle lots of different terrain, essentially making the tracker sled an all-terrain tracker sled.